Welcome to all. This is Tanu Gupta from Akgec Engineering College. Today I am going to present or discuss a very important topic related to machine learning. It's Bellmen equation in the reinforcement learning. First, we understand what is reinforcement learning, then comes toward the learning task of reinforcement learning, that is a Bellmen equation. Okay. So, as we already discussed in our previous lecture, there are three types of machine learning technique. First one is supervised learning machine learning technique. Second one is unsupervised machine learning technique. And now third one is reinforcement learning. In the supervised learning technique, the data is well labeled. In the unsupervised learning technique, there is no well labeled data set. In the reinforcement machine learning technique, reinforcement learning, it's a feedback-based machine learning technique in which an agent can be in any robot or can be any software, learn to behave in environment by performing the action and seeing the result of the action. So this is a definition of reinforcement learning. Reinforcement learning is a feedback-based machine learning technique. What is the meaning of feedback-based? The meaning of feedback means it's run on the feedback. If it will take a positive feedback, then it will act accordingly. It will take if in case a negative feedback, it will act accordingly. So I'm trying to say that reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing some actions and seeing the result of an action. For each good action, the agent will get a positive feedback, and for each bad action, the agent will get a negative feedback or a penalty. So, according to this scenario, in the reinforcement learning, an agent will learn how to act properly using the feedback of positive or a negative feedback according to their any good or bad action or any accurate or inaccurate action. So in the reinforcement learning, the agent learn automatically with this feedback and improves its performance. So in the RL technique of machine learning, the agent learn automatically. It will not take help from the previous data like in the or a well-labeled data set, unlike in the supervised machine learning technique. The agent will learn automatically with the feedback that given by the environment and improves its performance. So the reinforcement learning, the agent learn automatically using the feedback without any labeled data set. Since there are no labeled data, then agent is learned to bound by its experience only. There is not any labeled data, so that the agent will learn by its own. It will learn only by on hit and trial basic. So we understand the concept of RL by using this diagram. An agent that can be in any robot or software program, an environment, the agent perform some action and changes its state, one state to the another state, and take the rewards. It can be a positive reward or it can be a negative reward. For each good action, for each correct action, the agent will get a positive feedback, and for incorrect action, the agent will get a negative feedback. We as a human being also experience with our action. If we perform a task, and if we perform a task and we receive a good reaction from all other, then in case we have a positive feedback. If our actions is wrong and somebody and that are not fulfill our expectation, then it will be a negative reward. Same like in the reinforcement learning, an agent that can be in any robot work in an environment by changing its state by performing some action to changes its state from one state to the another state and take a reward that can be a positive or negative or a penalty, and learn by an hit and trial basis. So this is a basic concept of reinforcement learning. Reinforcement learning, in summary, it is a feedback-based learning technique in which an agent learns to behave in an environment by performing some action and by seeing the result of that particular action. For each good action, the agent will get a positive feedback, and for each bad action, the agent will get a negative feedback, or we can say a penalty. So these are the basic terms we are going to use in our Bellmen equations in our reinforcement learning task. First one is an agent, as we discussed, the entity that can perceive the environment and act upon it. What is an environment? A situation in which an agent is present. Environment is a situation which an agent is present. Third one is action. Actions are the move taken by an agent. Actions are the move that is taken by an agent. Now the state. State is a situation returned by an environment. If agent is in state, current state S, and the agent performed some action A, then it will be in a new state, that is an S dash. So state is a situation returned by an environment after performing some action. Reward, a feedback return to the agent from the environment. What is a reward? Reward, it can be a positive and negative. Reward as a feedback returned by an environment to the agent. It can be a positive or it can be a negative. Policy, what is a policy? Policy, or we can say it is a strategy applied by the agent for the next action to be performed on the current state. Policy, what I am trying to say, that policy is a strategy that is used by an agent for taking an action to change its state from one state to the another state by performing some action. Now the value. Value is expected long-term return with the discount factor. Value is we can say that value is the value that is appropriate for that action. If we have a multiple status to reach out the final destination, then what path we followed to reach the final destination? So in this case, we assigned some value to that path so that we can try to follow a maximum, or we can say a optimal path to reach from the source to the destination. So these are the basic terms that we are going to use in our Bellmen equation or in our reinforcement learning task. One example we have to consider, like self-driving car navigation. This is an example of reinforcement learning. For example, like Tesla. Tesla is a self-driving car. Learn how to drive safely and efficiently throughout the city. This using a concept of reinforcement learning. In this, the agent can be a self-driving car AI system. There is an inbuilt AI system, can be a agent for this self-driving car. Environment is a proper, we can say a real world road network or a traffic. State, current information about the car and the surrounding. What is its current state of an agent? The information about the car, about the surrounding, what is the speed, how to maintain a speed, what is the position, nearby vehicles, traffic light. The basic information or the current station or current situation of a state, that is known as defined by a state. Now action. What is action? In this example, the car possible decision. Car possible decision, when to apply a brake, when to apply a accelerator, when to turn right, when to turn around, and so on. These are the action that will be performed by a car. Now the rewards. Rewards, it can be a positive feedback or a negative feedback. For each good or a right direction the car move, then it will get a positive feedback. If there is a crash or there is a heartbreaking, then it will get a negative reward, as we can show in the -1 form. Okay, now understand how the reinforcement learning work. Environment. In this example, we can understand a room. Environment can be a room, a maze, a football ground. Agent such as AI robot. So we can say that a small grid in which there are a number of cells. Agent can be in position S9. This is a final destination. This is a fire pit, and this is a small fixed wall. Okay, now the robot has to reach from this location to this location. There can be a fireball. This is a destination. This is a fireball. So what approach we followed to reach from source to the destination? What is the learning task that reinforcement learning is trying to do to reach the source to the destination? We understand the learning task by using the Bellmen equation. So now comes to the Bellmen equation. Bellmen equation, it will be difficult for the condition for the agent when he should go up and down when all the grids have the same value. So the above approach, so the Bellmen equation is suitable for the agent to reach the final destination. Bellmen equation is introduced by the mathematician Richard Bellmen in the year 1953. That is why we said this equation is a Bellmen. So in the Bellmen equation, we use some notations. For example, action performed by agent is referred to as A. If there is we represent action by a symbol A. The state occurred by performing the action. When agent can be in a state S and it performs some action A to reach to the another state, then state performing the action is stand for S. So we in all we represent an action by a symbol A and state by a symbol S. The reward or feedback obtained for any good or bad action we represent by the symbol R. R is stand for the reward. For each positive action, it will get a positive reward. For each negative action, it will get a negative reward. Discount factor is denoted by gamma. Gamma is a constant value which we added to the state changes to find the optimal solution. So the Bellmen equation can be written as V of S, the value of state S value calculated at particular point, RS of A, reward at state A by performing some action A. Gamma is a discount factor and VS dash is a value of the previous state. This is a value of a current state. This is a value of a previous state. Gamma stands for discount factor and this is a reward to reach the destination. So in the above equation, we are taking the max of the complete value because the agent trying to find the optimal solution always. The discount factor is a constant to reflect the value of the signal time in reinforcement learning as we discussed earlier. Now consider an example as we already discussed before. We have a small maze environment in which there are a 12 grid, small grid. Agent in position S9. This is a final destination. This is a firewall and this is a solid wall. So agent have to reach from this block to this block. So how the Bellmen equation is used to calculate the value for each cell and then find a optimal path from reach to S9 to the destination space. So for the first block, we have to start from S3 at the final destination. We have to calculate the Q value for each of the following cell. So first we calculate the value of S3, value of S3 by using this Bellmen equation. Reward S of A. What is the reward of this state? The right of this state is a final destination. Then that is why he will get a maximum reward +1. If any cell is directly reached to the final destination, then he will get a +1 reward. Else in other situation, the value of reward is equal to 0. So the value of RS of A would be 1 for the state S3, because from right of this cell we will reach to the final destination, plus the value of discount factor. For this example, we considered a discount factor is 0.9. So 0.9 multiply the value of previous state, because we started at this location, so there is no previous state. That is why the value of Vs dash is 0. So what is the value of Vs3 cell would be 1. 1 plus 0, 1. So the value of this cell would be 1. Now calculate the value of the grid S2. The reward in this case will be equal to 0, because the right of this is not a final destination. That is why the reward in this case will be 0, plus discount factor 0.9 multiply the value of that previous cell. What is the value of previous cell which we calculated in the above step? That is 1. So 0 plus 0.9, the value will be 0.81. So we fill the grid by the value 0.81. Similarly, we calculate the value of the S1 block. The reward in this case also 0 plus discount factor, the value of previous cell, that is 0.81, and we calculate the value. Now similarly, we have to calculate the value for S3 block, S2 block, S1, S5, S9, S10, S11, S12. Using the previous value, we have to follow the path S3, S2, S1, S5, S9, S10, S11, S12. Then we left the value of S1. How we calculate the value of S7? S7, either we take a value of previous cell 0.53 or 1. But what is the maximum of these two value? Is 1. By taking this previous value, we calculate the value of S7. This would be 0.9. Now using the previous value of 0.9, we calculate. Okay, now we have to fill the value of S7. For calculating the value of S7, what the value of the previous block we have to take? We are taking 0.53 or 1. But what is the maximum of these two values? That is 1. So for S7 block, the maximum of RSA would be equal to 0, because there is no direct we are not going to reach from S7 to S4 directly. So the reward of RSA is 0 because there is no reward at this state. 0.9 multiply the value of previous state, that is maximum, that is 1. So the value of VS7 is 0.9. So we are going to fill this value by 0.9. Now by using the value of 0.9, we again calculate the value for S11, S12 for S10 block and write that value which is maximum of these two values, because we previously calculate the value of S10 by using the previous value of 0.66. We calculate the S7 by using the S10 previous value by we are already calculate the value of S12 by using the previous value of S11 block 0.81. Now if agent follow this path and by using this previous value, what are the changes in that grid? We stop when there is no changes in that grid. Okay, so by using this previous value, we have to calculate the value for S11, S10 and S12. So for the S11 block, the reward will be equal to 0 because there is no reward at this state. Maximum 0.9 discount factor multiply what is the value of previous, that is 0.9. 0.9 that is 0.81. This the value of S11 is 0.81. What will be the previous value? That is 0.53. Maximum of 0.53 and 0.81 between these two values is 0.81. So we replace the S11 block value 0.3 by 0.81. Again, we have to calculate the value of S10 block. Reward 0, gamma factor 0.9 multiply previous value of this state, that is 0.81. So multiply 0.81 by this is equal to 0.73. What is the previous value of S10 block? That is 0.59. And what is the maximum of 0.59 in between 0.73? 0.73. So that is why we replace the value of S7 block by 0.73. Now again we calculate the value for S12 block. We follow the same procedure and choosing the maximum value for the each grid until we reach the final point. Now after filling this grid with the maximum value, agent can be in any position, like in this grid, in this grid, in this grid. They followed a path that has a maximum value. For example, if the agent are in this position 0.6 or we can say a 0.9, then what are the possible action they have to perform? In this direction, in this direction, in this direction. There can be a solid wall, there is no option. In the left 0.81 and the right is 1. So what is the maximum value? 1. So if agent are in this current situation, they follow a path like this, and if this position they followed a path, they have the possible action like go down, and but he will get a maximum reward at this stage, that is +1, or is the final destination. If agent are in this position, then they follow this path. If agent are in this position, then they follow this path or this path, but they both have the same value. Then it check the another condition, they both have the same value, then it will check another condition, then this value is maximum. So when the agent are in the S1 block, they follow this path to reach the destination. So according to this Bellmen equation, an agent would learn how to learn with an environment to reach from the source to the destination by gaining a maximum possible reward. Thank you so much. This is now for now. This is a Bellman equation. So if you have any doubt, then you can ask or comment in this video. Thank you so much.